Hello everyone. Welcome to Lecture 3 in Kinetics and Equilibrium. We're going to focus in this lecture on the basic reason why a reaction occurs. It's called collision theory. Okay, so our learning target here is designed to describe the steps required for a chemical reaction to occur using collision theory and predict how changing concentration, temperature, and surface area will affect a reaction's rate. Okay? So let's get to it. What are chemical kinetics and rates of reaction? Well, kinetics is a study of rates of reaction, so they're kind of the same thing, how fast a reaction occurs. You can speed them up, you can slow them down, but the question is how? So they can be manipulated if the conditions of collision theory are manipulated. Well, here's kinetics, reaction rate, collision theory, reaction mechanism, factors affecting the rate of reaction. We've got 6 factors, okay? Nature of reactants. Well, ionic compounds react faster than covalent compounds. That is just the nature of the different classes of compounds, okay? Ionics faster, covalents slower. The number of steps in the reaction. We don't do reaction mechanisms, but if you can think about it, certain reactions have more steps, so they would probably go slower. Less steps make it faster reaction as well. So the fewer steps in a reaction mechanism, which is at that activated complex, the faster the reaction will go. What is collision theory? These are the rules for any reaction to occur. First, a collision between our particles reacting must occur. You can't have hydrogen and oxygen combining to form H2O if the hydrogen and oxygen don't first collide with each other at the atomic level. The collision's got to have enough energy as well, because otherwise the atoms will just bounce off of each other. So you have to have enough energy to overcome the activation energy of the reaction. Got to get up over the hump so that the products can form. Collision must occur with the correct orientation so the reactant particles can merge. So even if the particles collide with the right amount of energy, they have to collide in the correct orientation. It's kind of like shaking a hand. If you don't do your handshake correctly, it doesn't feel right and it's not considered a handshake. It's not an effective handshake. It's not an effective collision if the atoms don't hit each other in the right orientation. Well, any collision with correct energy and orientation will result in a reaction, and that is the basis of collision theory. How can we manipulate the rate of a chemical reaction? Let's see. We're writing this down. So if we want to increase the rate of reaction, make it go faster, we should increase the concentration of the reactants. More stuff in there, faster they're going to react because they're going to hit each other more often. If we want to slow the reaction down, we got to decrease the concentration of the reactants. If there's fewer particles around in there to react, the reaction will go slower. Okay, you can decrease that by changing the concentration. Increase the rate. Well, you can heat it up. Increasing temperature makes the atoms have more energy for when they collide, they're more likely to have an effective collision. Decreasing the temperature, well, will decrease the rate because the atoms don't have as much energy when they collide with each other. They won't activate the reaction. When we're talking about gases, if we increase the pressure of gases, it's like increasing the concentration. Those atoms are closer together and they'll hit each other more often if they're gases under pressure. So if we wanted to decrease the rate of a reaction that had gases involved, we would decrease the pressure because then those particles of gas won't bump into each other as often and won't react as quickly. Now, surface area is cool because if you want to speed up a chemical reaction, you got to increase the surface area because if more surface of the powder or solid is exposed, there's more sites for collisions to occur. And if you want to slow down a reaction, you decrease the surface area. So you would have fewer chemical reactions. So smaller particles react faster because they have higher surface area. Big chunks react slower because they have lower surface area. Catalysts are cool because they increase the reaction rate, like acting like a traffic cop directing traffic. They make the reaction occur. They bring the reactants together in an orderly fashion with the right energy to make the reaction go quickly. To decrease the rate, well, There are reaction inhibitors that would slow a reaction down, but that is not part of the regular curriculum. To decrease the rate, you'd add an inhibitor, which is the opposite of a catalyst. It deliberately slows down the chemical reaction based on collision theory. So that's it, the basics of what kinetics is, rates of reaction, and what collision theory is how a reaction occurs, the steps necessary. So thanks for watching. I'll see you in lecture 4, where we'll move on with our curriculum. Bye.